Geometric series is the sum of all the terms in a geometric sequence. And remember, a geometric sequence goes up by multiplying by a common ratio. So the sum of the series will equal your first term times 1 minus your ratio to the power of the number of terms divided by 1 minus the ratio, and r cannot equal 1 because that would make it undefined, 0 on the denominator. So we want to determine the sum of the first 12 terms in the geometric series, 3 plus 12 plus 48 plus 192. So s of n, we don't know, so we want to find s of 12, which makes our n equal to 12. Our ratio will be our second term divided by our first term, so 12 divided by 3, which is 4, and our t1 is equal to 3. So we plug this into our equation. S of 12 is equal to 3 bracket 1 times 4 to the power of 12 divided by 1 minus 4. And when you type this into your calculator, you should get 16,777,215. So the 12th term, the sum of the 12 terms would be this. For the next example, the sum of the first 14 terms, so sum of 14, n will be 14, is 16,383. So we know our sum of 14 is equal to 16,383. Our common ratio is negative 2. Determine the first term. So we want to find T1. So we plug this into our equation. 16,383 is equal to T1, bracket 1 minus negative 2 to the power of 14, divided by 1 minus negative 2. So this should get 16,383 is equal to T1, bracket negative 16,384 divided by 1 minus 2 is 3. We're going to multiply both sides by 3 to get rid of the denominator. So 49,149 is equal to negative 16,384 T1. Isolate your T. So you divide by negative the 16,384 on both sides. So that means that T is equal to negative 3. So the first term in your sequence would be negative 3. So for the next sequence, we have our first term, we have our common ratio, and we have our last term. We want to find the number of terms. So Sn equals, we don't know what n is, but we know that it's equal to negative 4. Just kidding, we don't know Sn. We want to find Sn, but we need to find our n first because we don't know n. Our ratio will be negative 15 divided by negative 3, which is 5. And our Tn would be equal to negative 46,875. And T1 is negative 3. So we need to use the formula from yesterday. So Tn is equal to T1 r to the n minus 1. Tn is negative 46875. It's equal to negative 3 times 5 to the n minus 1. Divide both sides by negative 3, and we should get 15,625 is equal to 5n to n minus 1. Now we need to put 15,625 into base 5. If you take 15,625, divide it by 5 until you get to 1, and count the number of times you divide it, and you should get 6 equals 5 to the n minus 1. Now we can solve for our exponents. So 6 is equal to n minus 1. So 7 is our n. So this term right here is 7. Now we have enough information to solve for our sum. You can only ever have one variable missing. So S of 7 is equal to T1, which is -3, bracket 1 minus, your common difference is 5, to the power of n, which is 7, divided by 1 minus 5. And if you type this all into your calculator, you should get -58,593. A person takes tablets to cure a chest infection. Each tablet contains 500 milligrams of an antibiotic. About 15% of the mass of the antibiotic remains in the body when the next tablet is taken. Determine the mass of the antibiotic in the body after 3 tablets and after 10 tablets. So our T1, right when you take your first pill, it's at 500. Our R is 0.15, so 15% of it's left. And n is going to equal 3 or also 10. We're going to do both. So first let's do 3. So the sum of 3 tablets is equal to 500 times 1 minus 0.15 to the power of 3 divided by 1 minus 0.15. Type this into your calculator and you should get 586.25 milligrams. So there's about 586 milligrams of the antibiotic in your body by the time you take the 3rd tablet. When you take the 10th tablet, it'll be 500, bracket 1 minus 0.15 to the power of 10, divided by 1 minus 0.15, and you should get 588.2352. So when you take the 10th tablet, there will be 588 milligrams of the antibiotic in your body.